The Arts and Crafts Wood Gear Clock, designed by Clayton Boyer, with plans available on his website. This is a impulse-driven clock with electromagnet, something similar to the Toucan, also designed by Clayton. The plans come, which as usual, are very comprehensive and would allow anyone to build this clock by following the plans. I decided to deviate slightly from the plans. One thing just to be a bit different. I'm not saying that my version is better than the original. It's just another version. Another reason for my alteration was the fact that I am a bit limited in gear cutting to about 6mm thick. These plans call for hardwood gears which are inherently thicker, so I opted for the Baltic Birch ply gears, 6mm, so that's one of the changes. The other changes, I decided to put in a third frame, as well as a front frame and a back frame. I decided to put one in the middle, and this gave me more options for a couple of changes that I decided to make. One of which was to put a hub on the cannon wheel, so instead of putting a grub screw through the cannon wheel, I mounted it in the front frame. These are the basic components of the clock prior to assembly. You can see the birch plywood gears having been cut out along with the frames. The long frame at the front is actually the front frame. It can be seen there how it's recessed to take the cannon pinion hub. The top was made of hardwood, two pieces of it joined together, and the rest of the clock is just basically various types of hardwood and with some contrasting colours where required. The joints were made with dowels. I staggered the dowels so that they could go deeper and they interlock with one another for extra strength as well. So it turned out to be a good system, the one I preferred. I ended up putting stiffeners on the top because I found that all that was hardwood, it was cupping. So I tried to straighten that out, stop it cupping. I jointed doweled the bottom cross member that holds the coil, and here we have the gears and the pawls. This shows the three frames set up on the top for marking out. These were doweled to the top so that they always locate back in the same place should they be moved, and the idea is to screw them down and not glue them, so that in the event that in the future work needs to be done on a clock, it can be done by just unscrewing those frames. This is a temporary setup just to line them up, and I kept the solid center in the dial temporarily till I also marked that off the center, directly off the frame, so avoiding having to measure. Another technique for marking out without measuring up is to use these dowel pins. They're used by drilling one half of the doweled component, putting these pins in, then offering it up to the other part of the dowel component, and with a light tap the position is marked for drilling, so it's accurate and quick, and again without too much measuring. So that's quite a good method for doweling. This jig is for setting up the wheels and pinions. It works by getting the pinions working together, the wheels and pinions, and then using those centers, the shafts at the back have points on. If this is then laid on top of the clock frame with a slight tap, it will mark the positions of the arbors. Again, it's an accurate layout method without measurement. Works quite well, I find. So that's another personal preference. These are the birch plywood gears. The poles were cut out using the original drawing glued to wood. The idea is to take copies of the original drawing for reference and then use the originals to cut out the components required. This pendulum is similar to the one I used on the Toucan clock. I use a solid rod at the top to stiffen it up a bit, because I found that long pendulums tend to vibrate too much. This is the modified cannon wheel with the brass hub attached to it. It's obviously much stronger. It's also easier to fit because it just slides on the arbor and then it's locked in with a grub screw. Because this is recessed into the front frame, it doesn't change the layout of the rest of the gear train. This is the clock face, made of 8 pieces of wood. It's actually 2 layers of 4 pieces which are staggered, and the joints are staggered to make it stable and strong. And the dark coloured woods are used for the what would have been the number positions. I use bearings quite a lot in this build, and they're cheap bearings which come full of grease, making them quite sluggish. They're not tight, they're just sluggish because of the grease in them. I found a good way of sorting that out is, rather than wash them in solvent or whatever, I just simply put some light oil on them in this jig and then rotate it quite quickly and let the oil dissolve the grease or thin it down or whatever, and the end result is it's a nice free bearing. Care should be taken here, as with all operations, and make sure it's done safely. High speed could be achieved, so it could be dangerous or cause injury if not done properly. Anyway, the result is that you end up with a nice free bearing, having spun it, and it works well in the clock then, little resistance. This shows the hub with the grub screw attached, and here we have what I use for cutting the gears. Basically it's a pantograph router with a 2-to-1 ratio, whereby a stylus moves around a pattern and the router moves half that distance to produce a template. The pattern is actually 4 times the size of the original, of the required gear. So I'm following the pattern with the stylus to cut out the template. It's actually only a section of the cog, it's not the whole cog. I only need a section of it, which will be then copied several times onto the finished article. Once that's been done, and I have a template that's double the size of the component, I can then set this up for cutting the actual gear. So the stylus has changed to half its size and the cutter has changed to half its size, and the gear can be cut out by following the template. So part of the gear is cut, then the rotary table is rotated and another section of the gear cut, and so on until we end up with a complete gear. And the rotation of the rotary table is very precise, so it does a very good job. The end result is a nice gear. One feature of this is that as we're reducing the size of what we're doing, we're also reducing any errors, so it ends up quite accurate and more than enough for this job. I found cutting gears very tedious by any other method, and whilst a lot of people won't have this equipment that I've got, I found that was my best method of doing it. This is the electrical socket mounted onto a stainless steel washer ready for mounting. I made the top slightly thicker for the reasons I said before. I'm only screwing the frames to it, not gluing. I already spoke about the bearings, and of course some of it requires brass tube as well. The hands were thinned down where needed to balance and then stained. The coil was made and fitted to the cross member with the appropriate lid on it. My other video may be helpful with that. I've already mentioned the pendulum, and here we have the frames having been stained, are now ready for assembly. So it's a case of making up the drivetrain, which can be tested by getting the frames together and testing it. The rest was just assembly and then a finish before we can finally check it out. And it's a great feeling when you first fire the thing up and it actually works. You realise that it's now become a clock, not just a heap of wood that has been assembled. So very, very satisfying when that happens. The power supplies on this clock is as with the Toucan. I found that I started off with 9-volt supply, but as things freed up on the clock, it tended to overdrive. So a bit of experimentation showed that the clock will run on as little as 4.2 volts. However, that's a bit weak. It doesn't take much to stop it at that level. So I found that the best voltage is 5 to 6 volts. Anything over 6.5 volts it overruns, and anything below 5 it tends to be a bit weak. Here's another view of the back of the clock with the bearings in the escape wheel, and the clock's swinging away very nicely. No doubt will give years of good service. This is an attempted close-up of the crown, the cannon pinion in the front frame. You can just see where the grub screw can be tightened up. Then we have the middle frame, which is also supporting the minute arbor with another bearing, and then to the right of that we have the pendulum arbor, which is supported between the middle and the back frame, both of which have bearings in them. By having this dynamic arbor, it meant I didn't need the phenolic tube and the rest of it that goes with that. So that was my setup. And lastly, here's a few just shots of the clock as it's finished. So I hope anybody who attempts to build this has success, and thank you for watching the video.